York State now requires higher levels of airtightness in newly constructed and renovated residential buildings. The new energy code also requires a test to prove that the building meets specified requirements. In this video, we will discuss the basic air sealing and blower door testing requirements of the 2016 New York State Residential Energy Code. If you are building a single-family home or a residential building 3 stories or less, this law applies to you. The new standards are more stringent than in previous versions of the code and require a rigorous approach to air sealing. According to the new energy code, when a residential building is completed, it must have an air leakage rate of 3 air changes per hour or less at a pressure differential of 50 pascals, commonly referred to as 3 ACH 50. This is much tighter than the previous energy code. Air changes per hour is a standardized measurement used to describe how leaky a building is. It indicates how much air leaks into or out of a building. To give you an idea of how tight 3 air changes per hour is, imagine a 2,500 square foot house. Now imagine that all of the cracks, gaps, and holes in the building are combined to make one large opening. A building with 10 air changes per hour would have a hole in the wall equivalent to the size of an open window. A building with 7 air changes per hour, the requirement of the previous energy code, has leaks that add up to a hole this size. Finally, a building with 3 air changes per hour would have a 150 square inch hole. This is the maximum amount of air leakage you are allowed in a newly constructed or renovated residential building today. Some standards, like Passive House, go above and beyond this requirement with combined air leakage the size of a cell phone. The good news is that it's not difficult to reach these airtightness levels. It just involves some early planning and attention to construction detail. What are the key strategies for achieving 3 air changes per hour? In order to meet new standards for building airtightness, the air barrier will need to be continuous. As many holes, gaps, or cracks as possible need to be sealed. The best way to achieve a continuous air barrier is to plan it in advance. The designer needs to specify air sealing details. The builder needs to plan for required materials before construction begins. Finally, create an integrated work plan for crews and subcontractors so that air sealing tasks can be appropriately sequenced and coordinated by all trades. Air sealing materials that form the continuous air barrier need to be applied at appropriate times during construction. It is much more difficult and expensive to install air sealing after construction is complete. Now let's discuss how to create a continuous air barrier. The code lists 15 locations that must be properly air sealed in order to create a continuous air barrier. All 15 combined can be boiled down to air sealing the attic, windows, walls, and floors, and air sealing the places where floors and ceilings meet walls. Let's discuss the attic first. Gaps where the walls meet the roof or attic and unsealed penetrations in the ceilings are problematic because as warm air rises, it escapes through the holes and draws in cold air from below. This wastes conditioned air and increases energy bills. When subcontractors install HVAC equipment, ducts, vents, or flue shafts, make sure the penetrations are sealed after installation. New windows need to be factory rated with an air leakage of 0.3 cubic feet per minute or less. Each window should have an NFRC label with its rating. Don't remove these labels until all inspections are passed. When the window is installed, the installer must seal around the windows. Seal the rough openings during construction, then caulk between the unit and the rough opening after installation. The interior window trim will provide the final layer of air sealing. Finally, you will want to pay attention to the places where walls meet floors, including through floor, rim joist, and floor to slab. As work proceeds, make sure to visually inspect for gaps, cracks, and potential air leaks. These will be difficult and expensive to repair once the walls are closed up and could cause you to fail air tightness testing later. Specifically, during rough-in, make sure each subcontractor seals penetrations that break through the continuous air barrier, including penetrations for mechanical ducts, plumbing vents, electrical outlets, recessed lighting, or HVAC registers. To recap, key strategies to achieve 3 air changes per hour include planning for air sealing in the design phase, sourcing correct materials, making a plan for collaborating with subcontractors on sequencing of air sealing tasks before construction begins, creating a continuous air barrier, and checking for gaps and cracks as construction proceeds. Don't wait until the end. Now let's discuss the blower door test. Once construction is complete, including all final envelope penetrations, it is time for the blower door test. Projects must use a blower door test to prove air tightness during final inspections. This is how it works. A powerful fan is set in a doorway and creates a pressure difference between the inside and the outside of the house, usually by depressurizing the house to 50 pascals. The pressure difference created by the fan pulls air in through all the leaks, cracks, gaps, and penetrations in the house. The amount of infiltrating air is equal to the amount of air flowing through the fan, called the flow rate, which is expressed in cubic feet per minute and converted to air changes per hour. The blower door test used to comply with the law must be performed when the structure is complete, including all drywall installed and all penetrations properly sealed, and all HVAC systems are installed. During the blower door test, exterior windows and doors, fireplaces, and stove doors must be closed but not sealed. All exhausts, intakes, makeup air dampers, backdraft, and flue dampers must be closed but not sealed. Heating and cooling systems should be turned off. Supply and return registers must be open. The test results need to be included in a written report for the code official. If the infiltration rate exceeds 3 air changes per hour, you will have to repair the air barrier and retest. It is good practice to perform preliminary blower door tests during construction while the walls are still open to find any unexpected air leaks. It's much less expensive to seal holes before the walls are closed. Hiring a certified professional to perform the blower door test is easy. The 3 largest organizations that train or independently verify professionals performing blower door tests are Residential Energy Services Network, ResNet. Certified ResNet HERS raters must be proficient in conducting blower door and duct leakage testing. Annually, over 190,000 homes in the U.S. are blower door tested by HERS raters. Building Performance Institute, BPI, with professional certification, company credentials, home energy rating systems, and quality assurance services. And the National Association of Home Inspectors, NAHI. So remember, New York State requires that newly constructed or renovated residential buildings must use a blower door test to demonstrate an air tightness of 3 air changes per hour or less at 50 pascals. There are 3 major organizations that train blower door testers. Checking their websites and asking colleagues for recommendations are good ways to find a qualified person to perform a blower door test. Check out our website for more information about complying with the code in New York City and New York State.